Alrighty there. Hi everybody. Here's the review, one of the review solution videos for the Math 3 Pre-Calc Final Review. This is about the trigonometry problems, so-called trig salad. Okay, so we're writing cosecant in terms of sine, and that's pretty simple just because that's almost how cosecant is defined, is 1 over sine. So that one's pretty straightforward. Making the point also that when A is in quadrant 4, the cosecant is negative, so your expression should be negative. But it's already negative because the sine is also negative in quadrant 4. So you don't have to do anything to this one here. It's a little bit more complex on this, the second one here. Tangent, writing tangent in terms of cosine means writing it as sine over cosine. Well, there's cosine, but we still have sine in there, so now we need to change the sine to something with cosine. And using the fundamental Pythagorean identity, we get the square root of 1 minus cosine squared on the top. Now, once again, let's think about the sign of this, the SIGN sign, positive or negative. So the angle is in quadrant 2, tangent in quadrant 2 is negative. So you have to make sure that at the end of the problem, this expression is negative. So, but we have a similar situation here because in quadrant 2, cosine is negative. So this expression, this fraction right here, as it's written right now, is actually negative. You do not put the negative sign in front of that square root. Just leave it alone, and your expression is negative. Okay, so that's good. Let's look at polar coordinates here and changing those into rectangular coordinates. Okay, x and y is rectangular coordinates, and x is always the r times the cosine of the angle, and y is r times the sine of the angle. So there's our little method for finding the x and y coordinates. So you just multiply 4 times the cosine of that. That's negative root 2 over 2. That'll give you negative 2 root 2. And the sine of 3 pi over 4 is also root 2 over 2. So 4 times that is positive 2 root 2. So there's your x and y coordinates for that same point. Looks like I haven't done this one yet. I'll have to let you do that one. I forgot that one. Anyway, let's keep going though. 240 degrees. All right, to find the x coordinate of that, I multiply r times the cosine of that. Cosine of 240 is negative 1/2, so 7 times negative 1/2, negative 3.5. Sine of 240 is negative root 3 over 2. Multiplied by 7 gives you negative 7 root 3 over 2. And so there's your x and y coordinates for that polar point. All right, so here the next problem is a number, an imaginary or complex number in polar form, and we're going to raise that to the third power. We would use what's called de Moivre's theorem to do that, and that theorem says that all you have to do to achieve this is to take your r value, raise that to the third power, and take your angle, your argument, so-called, and multiply it times that exponent. So 3 times 5 pi over 6 is 15 pi over 6, and so there's your new angle. This modulus, or r value to the third power, gives you 5 root 5. So here's the number right here in this box written in polar form. Okay, that's this number raised to the third power gives you all this. If, on the other hand, you wanted to change this back into rectangular form, all right, so kind of doing the same thing that we were doing in this previous problem, only now instead of x and y for imaginary numbers, it's a and b, but it's the exact same geometry and same method. So a is the r times the cosine of the angle, which in this case is 0, and b is r times the sine of the angle, which in this case is the sine of that angle is 1. So 5 root 5 times 1 is just 5 root 5, and that's where your I value gets on that, is bi, a plus bi. So that right there, that is actually the rectangular form of this same number. It's exactly the same number written in a different form. Let's do that one more time. This time we got an angle in degrees. The process is the same. Take the modulus raised to the third power, that gives you 1,000 this time, and then the angle is 110, just multiply that times 3, so you got 330. So that's pretty easy. Again, to change, so there's your answer right there. It happens that fast. It's almost just done before you know it. But to turn it back into rectangular form, if you had to do that, that there's your formulas right there. A for A and B are cosine and R sine. Just multiply out. It's almost like you're using the distributive property there for that problem, just as it's written out. And so there's your number in rectangular form. 500 root 3 minus 500i. Okay? All right, let's look at the next problems here. What all these have in common? Well, they all happen to equal 1. So that's just kind of using a variety of different little trigonometry facts to come up with that. In this next problem, we're using the double angle formulas, okay? The double angle for sine is 2 times the sine of the angle times the cosine of the angle. There it is right there, kind of spelled out for you. We had to figure out what the cosine of the angle is, though, because we're told what the sine is, but we don't know what the cosine is. All we know is that this statement here says that it's negative, less than 0. So you can reconstruct this angle, z, in a right triangle, knowing that the sine is 1 over 4. You can write that with the opposite 1 and the hypotenuse 4. You can figure out the other side of the triangle. We have the Pythagorean theorem is the square root of 15. And so now we know the cosine is adjacent over hypotenuse right there. And in this case, it's negative because it says so right there. And so you just multiply those three values together. 2 times 1/4 times negative root 15 over 4. And you end up with this value right here. So that's the sine of 2 times that angle. All right? Kind of going through that one more time, only this time the cosine angle, double angle formula. Well, here it is, cosine squared minus sine squared. Okay? And so, again, we'll set up a right triangle with the cosine equaling 1 over 8 in quadrant 2. Actually, this problem was in quadrant 2 as well. Anyway, there's our vertical side there with the Pythagorean theorem. Square root is 63, and so the sine is that over 8. And so cosine squared minus sine squared, do all of that wonderful fraction stuff, and you end up with negative 31 over 32. There's your answer. Let's flip it over and have a look at these here. Again, double angle for tangent. Not such a good problem here. I'll just scratch this one off. It just equals the tangent of pi over 3. I'm not going to go through that one because it's kind of a bad question. Next one, though, using the angle addition formulas for each of these. Here's your angle addition for cosine. You have to find two numbers that add up to 7 pi over 12. And one such pair is pi over 4 plus pi over 3, but there are others. So you put them into the formula, cosine, cosine, sine, sine. This is plus, so this is minus right here. Okay, so pay attention to that little aspect of the cosine angle addition formula. Then it's just a matter of putting in your values. All right, root 2 over 2, 1/2, root 2 over 2 again, root 3 over 2, multiplying and subtracting. You got root 2 minus root 6 over 4. All right, we'll do that one more time with the sine one. This time I tried to find some angles that subtracted to 195, so I picked 240 and 45. Same process really, sine, cosine, cosine, sine. This is minus, and so this is minus, so there's the same thing for the sine formula. Here we got negative root 6 plus root 2 over 4. Okay, inverse trig functions. Remember, the inverse trig of a number is the angle that has that number as its sine or cosine or its trig value. So inverse sine of 3 over 5 means the angle that has a sine of 3 over 5. And in this problem, we're going to take the tangent of that angle. Well, you can reconstruct that angle as in a right triangle. Opposite over hypotenuse, 3 over 5. You get the third side is 4, so the tangent is 3 over 4. Opposite over adjacent. Not too bad. Here's kind of a straightforward use of that inverse problem right here. Inverse cosine here, that means the angle that has a cosine of root 2 over 2, and that's 45 degrees, or pi over 4. Over here, the sine of pi over 3 is root 3 over 2. The inverse cosine of root 3 over 2, once again, is the angle that has a cosine of root 3 over 2, and that's pi over 6. Okay, here is the domain and ranges for these three inverse cosine functions, sine, cosine, and tangent. Make sure you have those. I'll let you look at those for a few seconds. Don't need to just say them, you can read them. In the next problem, back to using de Moivre's theorem, but first we had to convert this number from rectangular form into polar form. So as always, I recommend graphing that point as an a plus bi point. So a is -1, b is root 3, so it's that way 1 and this way root 3. That gives you sort of a little right triangle there with a hypotenuse of 2. And that right triangle, not coincidentally, is a 30, 60, 90 right triangle. And there's your 60-degree angle right down there, where my pencil point is. So that makes this angle here 120 degrees, or 2 pi thirds. So our number that we're going to raise to the 8th power is 2 cosine 2 pi thirds plus I sine 2 pi thirds. There's the number in polar form. Now we're going to raise it to the 8th power. Once again, you just take the modulus and raise it to the 8th power and multiply the angle times that exponent. So 2 to the 8th is our new modulus, and 16 pi over 3, that's 2 pi over 3 times 8. This kind of reduces down to 4 pi thirds. We talked about that in class today. I'll let you refresh your memory on how you do that. 2 to the 8th is just 256. So here's your number in polar form right there. It looks lovely, doesn't it? If you want to change that to rectangular form, that's A is our cosine, B is our sine, again, so just like on the other side of the page, and that works out to these values here, negative 128 minus 128 root 3 times I. Okay, last problem here, using the angle addition formula for tangent, okay, 105 degrees can be broken up as 45 plus 60, so there's your couple numbers off the unit circle. Tangent 45 plus tangent 60, that's 1 plus root 3. Tangent 45 times tangent 60 is just 1 times root 3. So 1 plus root 3 over 1 minus root 3. That's your fraction right there. That looks pretty nice, but it actually can be simplified further if you multiply the top and the bottom by the conjugate of this denominator here. So that looks like this. Conjugate is the same two numbers but different operations, so instead of minus it's plus. 1 plus root 3 over itself. Multiplying the top and the bottom of the fraction by this, you end up with 1 plus 2 root 3 plus 3 on the top and just 1 minus 3 on the bottom. And that simplifies down by just a couple of easy steps down to this very nice number here. Okay, we're done with that. Hope you enjoyed that. Again, if you have any questions, just go ahead and post them in the forum. Bye.